The Milky Way has up to 400 billion stars, and surrounding it are a seemingly infinite number of galaxies, each with even more stars. Surely then we should see bright dots covering every inch of our sky. No, but technically yes. Hi, welcome back. I'm Seti. I'm a PhD student in astrophysics, and today we are covering Olbers paradox. This is part 2 of my mini-series on astronomical paradoxes. Last time we covered the GZK paradox, and check back in 2 days' time for part 3. It's a bit juxtaposing, isn't it? To look out into the night sky with our own eyes and we can barely see something like Rigel, but then Hubble can take these absolutely beautiful deep space images of galaxies and see the starlight glow from them that are halfway across the universe, albeit with the somewhat yellowy orangish colour. And that might be our first clue to solving this paradox. We're of course discussing Olbers paradox, which was first postulated by, you guessed it, Johannes Kepler. It is true that Johannes Kepler actually did first come up with the idea, but it was Heinrich Olbers that was the one to reformulate it into the paradox that we know of today. But Olbers, presenting this paradox all the way back in 1826, didn't have the right physics at the time to explain why the paradox was wrong. Neither him nor Kepler knew that there were galaxies outside of their own, that the universe was observationally finite and expanding, nor did they know how the expansion affects the light within it. And these are all going to be key to solving our conundrum. There are 3 points that we need to discuss to solving this paradox. Firstly, the universe isn't infinite, therefore there aren't an infinite number of stars dotted around the sky. The further we look back into space, the further we look into time. This is because light doesn't travel instantaneously, it doesn't travel infinitely fast, so it takes time for the light to actually reach us and our telescopes, meaning the further we look back into space, we see earlier and earlier, to a point where there are no more stars because they haven't been formed yet. Secondly, we know that the universe is expanding. This discovery is thanks to Vesto Slipher, Edwin Hubble, and most importantly his assistant Milton Humason, who all measured the distance and radial velocity of galaxies, or nebula, and found that they were almost all moving away from us, and that distant galaxies were recessing faster from us, leading to the very famous Hubble's law. If we take the spectra of these galaxies, we find that all the galaxies that are moving away from us look a little bit redder, with the fastest galaxies looking the most red. This is called redshift, and it is created because the expansion of the universe is also expanding out the wavelength of the photons, meaning that the light emitted from these galaxies all become just slightly redder the faster that they move. Now, most stars in the universe tend to be roughly sun-sized or smaller, so they tend to look quite orangey to begin with. But if we shift them more towards the red side, their output tends to look a little bit more red or even infrared, meaning the most distant stars will look practically invisible to us, the humans with our human eyes who can only see in the optical range. So sure, Olbers' paradox is now solved. That explains why the sky is so dark to us, the humans who can't see within the infrared and beyond. But does that mean the sky is truly dark? The most distant light observable has been shifted way past red, past infrared, all the way into the microwaves. And if we use a microwave dish and point it at the sky at any point, we can see that it is completely covered in these microwaves. This is subtle, but it is everywhere, and this light didn't actually come from galaxies or stars or anything local. It actually came from the cosmic microwave background. The CMB marks the time when the universe was very young and very small, so everything was really compact and superheated. But as the universe continued to expand and therefore cool, the photons finally decoupled from protons and electrons, with the CMB being the last relic of this era. So yes, Kepler and Olbers were wrong, but they were also technically right in ways that they probably couldn't have even imagined. The sky is both dark and super bright, it just depends on the wavelength. Thank you very much for joining me as I discuss Olbers' paradox. Check back in 2 days' time for part 3 of my Astronomical Paradoxes series, and I hope you learned something new.